Bismillahirrahmanirrahim. Hello and welcome to Rahman Digital Production. This is lecture number 53 of Physics 5054. In this lecture, we are going to discuss pressure in gases. We will utilize the concept of a kinetic model of matter, and we will explain this topic. Ladies and gentlemen, first topic for today is pressure in gases. For that, let us consider a container filled with air and leave it at the top of the table for some time. It will remain intact and will not crumble. Why? Because there is air inside the container is putting pressure on the walls of the container, and that pressure is equal to the external atmospheric pressure. They are cancelling the effects of each other, and as a result, we are not witnessing that the container is crushing. Ladies and gentlemen, according to the simple kinetic model of matter, there are molecules inside the container, and this is the wall of that container. Because according to the Brownian motion, yesterday we discussed that molecules are in constant and random motion. Molecules are in constant and random motion, and they are colliding with each other and with the wall of the container. When they are colliding with the wall of the container, they are exerting a pressure on the wall. Accordingly, the wall is also exerting a force which is equal in magnitude and opposite in direction, according to the Newton's third law, which is denoted by these two arrows. This is colliding with the wall, it is exerting a pressure, and the wall is also exerting the same amount of force on the molecule but in opposite direction. And when they are colliding with the wall, they are coming back, and here if they are colliding with other molecules, they are deflected by a certain angle. So in this case, the wall exerts a force on the molecule, and as a result, molecules exert force on the wall, and this produces gas pressure. Why we are introducing the pressure terminology? Because force per unit area is called pressure. In this case, they are also exerting force on area of the wall of the container, and in this case they are also exerting a force. So we are introducing the term pressure because we understand that pressure is force per unit area, And according to this concept, the container is not crumbling, because whatever pressure the molecules inside the container are exerting on the wall of the container, that much force is exerted on the wall externally by atmospheric pressure. One atmospheric pressure is from outside and one atmospheric pressure is from the outside. So in this way, these molecules are exerting force on the walls of the container, and that is called pressure in the gases. Remember that we are leaving that container filled with the gas without applying any force externally. If we are increasing force externally or internally, they will crumble. But because both the external and internal forces are equal, so that is why they are not crumbling. So, using the concept of kinetic theory of matter, we can explain this scenario, that why the container is not crushing. Okay, now we are going to explain pressure volume relationship. Pressure volume relationship in gases, and for that particular purpose we will use this figure, which contains a cylinder and there is a gauge. This is a piston and this is a syringe, and there is air inside this, and this is air measuring gauge, through which we can learn that how we can measure the pressure. There is air inside this syringe. When we press this piston, it means that we are exerting a force on the air inside this syringe, and as a result, pressure will increase. How we will measure the pressure? There is a pointer inside this gauge, and it is moving when the pressure is increased in clockwise direction. And if we are dragging this piston outward, then the pressure is decreased, and as a result this pointer will move in anti-clockwise direction. So when we are applying the pressure, which can be noted from this gauge, so what will happen to the volume of the air, which can be measured from the calibration of this syringe? So this syringe is calibrating and it is telling us that how much volume is there inside the syringe. Ladies and gentlemen, in 1660, a scientist with the name Robert Boyle worked to establish the relationship between pressure and volume. And he found that pressure is inversely proportional to volume. What does it mean? It means that when we increase the pressure, the volume is decreased. And that is what the meaning of inversely proportional is. One quantity will increase and the other quantity will decrease. And whenever you want to see graphically without going in the mathematical complications, if it is a half U shape and this are like this, if it is like this as well, so it means that this is inversely proportional. When we are getting a straight line and that is passing through the origin, then it means that it is directly proportional. So it is directly proportional to 1 over V and it is inversely proportional to V. He found after a lot of deliberation and performing experiments, he devised a formula which is saying P is inversely proportional to volume. If we are writing it like this, then it is directly proportional to volume, which is not correct. So he is saying that P is directly proportional to, sorry, P is equal to kV. I told you earlier, then when you are replacing this proportionality sign, you have to introduce is equal to a constant. So from this we can get P is equal to V, where K is the constant of proportionality, P is the pressure, and V is the volume. We can generalize this formula that P1 V1 is equal to P2 V2, where P1 is the initial pressure and P2 is the final pressure, and similarly V1 is the initial volume and V2 is the final volume. So generally this is the relationship between pressure and volume. Ladies and gentlemen, let us explain this practically, that what does it mean? If we consider this model, there is a container in which there are gas molecules and there is a weight which is exerting a force on this molecule. Let me specialize it. For example, pressure is P1 is 1 Pascal and the volume is 10 meter cube. For example, V1 is 10 meter cube. So P1 and V1, let me write it here. P1 V1 will be equal to 1 into 10, which will be equal to 10 without going in the detail of the unit. Now when we increase pressure, and that pressure we are taking P2, and let us we are doubling the pressure to 2 Pascal. We are putting two weights of the same as in the case of the first one. So it will compress the gas and the volume will also be half. So V2 will be equal to, it was 10 and it will be 5 meter cube, for example. Ladies and gentlemen, in this case, P2 V2 will be equal to 2 into 5 and that will be equal to 10. So in the first case, P1 V1 is equal to P2 V2 and that is 10 and it is constant. So for two variable are two, that is P1 V1, P2 V2, P3 V3, P4 V4, and generally we can say that it will be a constant, which is this one. So P1 V1 is equal to P2 V2 and that will be equal to K, and we are explaining this in this particular case that practically we can uh, observe that pressure and volume is having the inverse relation. Increasing the pressure, volume will decrease. Decreasing the pressure, volume will increase. If we are again removing this, so volume will be increased and the pressure will be decreased. So Robert Boyles in 1660 devised this formulation for the pressure and volume relationship. We are talking pressure in gases, and pressure in gases is due to the collision of molecules with the walls of the container. When they, if I consider me as a molecule, if I am colliding with this wall, so I will put pressure on this wall. As a result, this wall will also put pressure on me, which will be equal in magnitude to the pressure that I applied and will be in opposite direction. So the wall will remain intact and it will not crush. So that is the concept of pressure. When we are inflating the tube inside the tire of a car, actually by pumping air inside the tube of the car, we are increasing pressure on the molecules, air molecules inside the tube of the car, and as a result those molecules are putting pressure on the walls of that tire and they are inflating it. So the same concept is used in our daily life as well. Once you understand this basic concept, many concepts will be cleared. Okay, that was the whole story about the pressure and gas. Now we learn theoretically, but let us do practical work. But before that, let me tell you one thing, that generally this is not derived, but I am telling you one thing very special, that pressure is inversely proportional to V. If we are increasing pressure 3 times, the volume will decrease 3 times. If we are increasing pressure 2 times, the volume will decrease. So whatever is here will be here as well. This is my general observation, and you have to keep in mind. So let us do work example, and that is on page number 134 of your book. Air at a pressure of 1.0 into 10 raised to the power 5 Pascal. So here initial pressure is 1 into 10 raised to the power 5 Pascal given. In a cylinder fitted with a piston, the air is now compressed by pushing the piston. So the same mass of air now occupies 1 over 5. Let the initial volume is equal to V1. So V2 according to the given condition will be equal to 1 over 5. I told you a technique, and I told you that if there is 3, it will be 3 here. So it is 5 here. So what will be the pressure? That will also be 5. And let us derive it. You have to keep, this is my own observation, not given in the book and anywhere. Okay, so they are saying V2 is equal to this one. Compress 1/5 of the original volume without any change in temperature. Yes, I forgot to tell you that Boyle's law will only work when the temperature is kept constant. If you are increasing the temperature of the molecules and suddenly you are pressing it, so this will provide internal energy to the molecule. So instead of pressing it down, it will move upward, and then the Boyle's law will not be applicable. So keep in mind that pressure at a fixed volume will be inversely proportional to the pressure if the temperature is kept constant. So here in the question they are also the temperature. Calculate the pressure of the air. So it means that we have to calculate this one. So solution is P1 V1 is equal to P2 V2, and that is we knew from Robert Boyle's law. In chemistry they are calling this as a Boyle's law. There is a Charles law, but Charles law is not included in your course, and there is general gas law. Only we are sticking to the course which is given in your book. So we have to find P2. So we will make P2 as a subject. So we will get P1 V1 divided by V2. So P1 V1 divided by 1 over 5 V1, because instead of this V2 we are putting 1 over 5 of V1. This V1 will be cancelled with this one, and we will only be left with P1 divided by 1 over 5, and P1 is given as 1.0 into 10 raised to the power 5 Pascal, and there is 1 over 5. Now P2 is equal to 5.0 into 10 raised to the power 5 Pascal. And ladies and gentlemen, I told you that if there is 5 here, this will also be 5. So 1 over 5 and 5. And you got it practically as well, that P2 is equal to 5.0 into 10 raised to the power 5 Pascal. So it means that the pressure is 5 time increase and the volume is 5 time decrease. If the pressure is increased 2 time, as in this case, the volume will also be reduced 2 times. It was 10 here and it is now 5 here. So it means it is reduced 2 times. From 10 divided by 2 is equal to 5. So this was the first practical implementation. And then we are having 9.2 is the worked example. And ladies and gentlemen, let me tell you that this is the final example of this topic will be concluded, and tomorrow we will turn to the exercise. Okay, 9.2 is saying, and they given us this scenario. There is a container which is graduated with 1 2 3 4 5 6. There is a piston and there is air inside this. So what they are saying, figure shows a syringe calibrated in centimeter with a gas tight piston. The cross sectional area of the syringe is 10 centimeter square. The syringe contains a mass of the gas with 100 kilopascal. So we are writing initial pressure, and that is P1, and that is equal to 100 kilopascal. So it means that we can write it 1.00 into 10 raised to the power 5 Pascal. They are saying, and the reading on the scale is 3 centimeter. So the volume is 3 centimeter. So initial volume V1 is 3 into 10 centimeter cube. 10 centimeter cube. You will say that they not given us 10. From where this 10 came? They only given us 3 centimeter, and the reading on the scale is 3 centimeter, means the height is, remember that volume of cylinder is equal to base area into height. So base area is 10 and then height is equal to 3, because we can see that from the cylinder graduation that it is this. Okay, they given us P2 is 60 kPa. How? What must be the scale reading if pressure is to be reduced to 60 kilopascal. So, final pressure P2 is equal to 60 kilopascal, and we can write it 0.60 into 10 raised to the power 5 Pascal. Now again we are using, we want to find the length. We will find the length, this one, and that is the height. I told you here, the base area into height. Let L be the scale reading. Let L be the scale reading for the final pressure. For the final pressure. And we have to find that final volume is equal to final volume is equal to V2. Volume of the cylinder is equal to L into 10 centimeter cube. L into 10 centimeter cube, like this. In the first case V1, they given us 3 centimeter. But in case 3, we have to find it, and we are taking this variable as a L. And that is our ultimate goal. So P1, V1 is equal to P2, V2. And here we are finding V2. So V2 is equal to P1 V1 divided by P2, and putting values inside it. 1 into 10 raised to the power 5, 1.0 into 10 raised to the power 5, and V1, they given us 3 into 10 centimeter, 3 into 10, and then P2, we are getting it as P2 is equal to 0.60 into 10 raised to the power 5 kilopascal. So this 5 10 raised to the power, and that is why we made it equal, that it will be cancelled, and when we calculate it, it means that 5.0 into 10 raised to the power 5 5.00 into 10 raised to the power 5 is cancelled, is 10 centimeter cube. 10 centimeter cube. Now I am coming here because I don't have the place there. So I am writing in this V2 we found. V2 is equal to L cross 10 centimeter cube, and we are finding L, so V2 divide by 10. And what is V2? V2 is given as, where is V2? We found it, 50. R, which is equal to 5 into 10, which is equal to 5 into 10, and this is 10, this one, so this 10 will be cancelled, so L will be 5 centimeter, and that is what our actual goal was, that we found 5 centimeter to be the length for final pressure. That's it for today. Thank you very much. Allah Hafiz.